So welcome to our OWASP agentic mass threat modeling is multiple agent system. Akram and myself will go through this threat modeling framework. We also call it as a MAESTRO framework. So we touch three main points. It's limitation for existing modeling framework and the MAESTRO. And Akram will talk about mostly on the threat modeling with MCP. A little bit about myself. Akram will introduce himself as well when his section he's talking about. So AI wrote a few books published by Springer, Cambridge University, Wiley. I also CSA fellow, co-chair two working groups, co-member of the OWASP Top 10. Recently, the instructor of EC Council for Generative AI for Cybersecurity. I also leading the boutique consulting firm for distributed apps. The traditional threat modeling, such as Strata, Dread, or Pasta, OCTAVE, or LINDDUN, they are really good framework. It certainly help application development in the shift to left stage to identify the threat so you can manage it. The problem is with agentic AI, it is not sufficient. We still can leverage it, but there is an issue that it cannot cover. So I list these 5 areas that traditional framework are not able to cover. One is non-determinism. The traditional in the code, once you write in the code, all this is deterministic computing. So with agentic AI, it's based on the model. It can hallucinate, or it has a prompt injection problem. So that's need new thinking in terms of threat modeling. Autonomy is also another area that is important because agent has a certain degree of autonomy from time to time, and maybe you don't have full autonomy, but if you don't have autonomy, that's not agent. So with autonomy, especially use of tool to have the action taken, that's a new threat model coming up. In traditional threat modeling, we always assume that there is the threat security boundary. We just need a threat model within the security boundary, and maybe the connection to outside, but not the outside model. That is not true with the agent, because you have the agent in one environment, like AWS, maybe talk to another agent in GCP using Google A2A agent, and you may make payment using Google agent payment protocol. So in terms of threat modeling, you need to go far beyond it. Traditionally, we do have the identities that you can define the policy in the deployment time. That's not true anymore. So the new, we also write a paper that Akram and myself and other people participated and published by Cloud Security Alliance. We actually get into very detail about agentic AI identity issues. The identity usually for agent is ephemeral, text-based, and dynamic policy enforcement. And that means when you threat model it, you need to thinking about it this way. And there's also agent to agent like communications, delegations, orchestrations. There's to the complexity and also have the issue with the blast radius. If one agent get compromised, it can impact another agent. So all this need a new framework to think. That's why we're coming up like with a 7-layer framework that it can deal with or uncover potential threat. If you think about the OWASP top 10, it's identify the threat. The threat modeling is to identify the new threat beyond the threat modeling. So there in our paper published by OWASP, we actually go further detail, and Akram also will uh, lead us to do it for the MCP using this MAESTRO framework. But essentially, in the foundation model, we look at the which model you use. If there's any potential threat, it could introduce. Then in the data operation, the second layer, we're talking about the vector database or RAG pipelines or even the memory, right? Some of the data poisoning or data leak will happen in the data operation layer. Agent framework, that the framework you can use like LangGraph or AutoGen, ClaudeAI, there's many. All those frameworks, they are used for orchestration purpose. They are not used for security. So you need the thinking about what potential security it could introduce. Maybe have a zero trust plugin on top of the framework. That actually I had a develop the plugin for AutoGen and ClaudeAI in my GitHub. If you're interested, you can reach back to me. I have the LinkedIn contact at the end. Take a look. Yeah, deployment infrastructure is really where you deploy. You deploy in a Kubernetes and put into the AWS, or you have deployed the serverless. So different deployment infrastructure has a different threat uh, possibilities, and so you need a threat model it. Evaluation is very important for agent, and there is no perfect evaluation model yet. So if uh, there's any threat against the evaluation or observability, that could be the issue, right? So we also need talking about that. Security is really a very important layer. I also say it's a vertical layer. Each layer need talking about security and compliance, right? But for this agentic AI, there's a distinctive security and compliance layer that could potentially you have the agent for SOC, the agent for Security Operations Center, and the agent for compliance. Um, and if you use it, what could be potential threat? Then the agent is ecosystem. And so in the future, the majority of internet traffic will be the agent to agent. The leverage maybe Google A2A or Cisco agency or IBM, right? There's different protocols there. Um, but what is the ecosystem's vulnerability? Things like if you have a marketplace, uh, how can you discover the price? What if there's impersonation of the agent? So all those is like the key idea is really to uncover all possible vulnerabilities. Maybe in your agentic AI application development, you may not reach all these layers, right? You may not have an agent ecosystem. You maybe just a simple tool. Then you just need to think about six layer, the top six layer here, uh, right? Or sometimes maybe you do not using framework. You're using your own code, maybe, right? So it's a little bit different, but this is trying to cover the base. You know what should look for in addition to OWASP top 10, right? Yeah, so how do you perform maestro threat modeling? Step one is you do layer mapping, right? The foundation model, what it is in like for your particular application, for example, Anthropic. Then it's using an external LLM or maybe using Claude, right? Or maybe using other models. And the data operation layer usually is provided the data access through the MCP server, maybe, right, to your applications. Agent framework, MCP could be itself as a framework. In most cases, for multiple agent orchestration, people using ClaudeAI with MCP or LangGraph with MCP. So you need threat modeling as well. Then the deployment infrastructure, yeah, it's where you deploy your MCP server. That's could be a big issue. Evaluation is important as well. So you have to have login and monitoring. Security compliance is also important, right? So design principles, ecosystem, how they connected. So then the second layer, we already talk about all this non-determinism. This is the second step. You go through it. So the key thing here, I have this open source tool. You can just git clone here and just add your Gemini API in the .env file. You should be able to run. You basically you can put anything here in the architecture description, like your agent architecture description. Then it will generate the diagram, and also you can generate analysis, and it will go to each layer to generate analysis. So yeah, I think this is what I have. If you want to get reach to me, that's my LinkedIn. Uh, with that, I hand over to Akram.
Yeah, thanks, Ken, for the great introduction. Hello, everyone. I'm Akram Sharif. So this is a brief introduction about myself. Next slide.
Okay.
Yeah, at a high level, as Ken pointed out, Maestro is a seven-layered approach which applies to different layers within an agent. And when I say agent, this agent is a runtime agent entity. You have the layer which applies to the data operations layer. You have one layer from Maestro framework, which is specifically allocated for the LLM model, another layer for the tool calling and things like that. So Maestro, it stands for multi-agentic environment, security threat risk outcome based threat modeling framework. If you take traditional threat modeling frameworks, PASTA, OCTAVE, other legacy frameworks, they may not be useful for agentic security threat modeling. And as you can see here, the kind of security threat attacks which might happen with agentic protocols like Anthropic's MCP protocol or Google's A2A protocols, they are pretty new in nature. When I say new, it is the threat vectors which are very new. Some of these agents, when they're running as embedded browser-based agents, you could have new kind of threat attack vectors which might come in from a Google email based plugin, or it could come from a man in the middle attack, or it could come from another browser web page or a tab that you might open in the same browser as well. So the kind of nuances involved in doing security threat modeling is very, very important. And that's where we have focused and built this Maestro custom agentic threat modeling. So no matter what kind of agent you're running, the role, the privilege, and the kind of access to the data sources the agent should have at runtime is very, very important. So it's important to have a micro segmentation based access control for the kind of grants that you provide to the data and for the tool calls which happen to the agents. Now, the agents could be written in any language. All these fundamental paradigms are very important. If you take a fundamental MCP based protocol, MCP client is there, and then you have an MCP host, and then you have an MCP server. And then you have different protocol transmissions which happen either via STDIO or via other transport layer protocols. Some of these transport layer protocols are very naive and they are they're vulnerable to security threat attacks. Now, how do we use security threat modeling techniques with Maestro so that you can detect such security threat attacks and then you can do mitigation as well? That's what we have covered in some of the research papers and in the open source project. Next slide, Ken. And as you can see here, this is the detailed summary of the Maestro threat modeling. So different layers are categorized here. The core logic, the session, and the HTTP layer. And then with respect to the foundation models, we have the APIs and then the cloud-based services. And then deployment infrastructure is very critical. Most of these agents are deployed as container-based agents. Kubernetes containers. Now you could use frameworks like Spiffy, Spire, and then workload identity management in combination with Maestro threat modeling framework to achieve better business outcomes. And then the framework that we have written is pretty much agnostic. It can be applicable for LangGraph, Llama Index, Baby GPT, Microsoft AutoGen, regardless of the agent framework that you select with TypeScript or Python, we could still use Maestro. That's one critical advantage. Next slide, Ken. At a high level, let's say there is a particular security threat attack. As you can see here, this is an injected MCP service-based security threat attack where there are a list of tools which were there previously. And then because of a poisoned context can actually come from the data or it could come from the prompt. Now, because of such a threat vector, there is a runtime specific security threat attack which is actually occurring. Now, how do we detect this by using the Maestro technique is something that we have discussed in the blogs and in the white paper and in the open source GitHub projects. We would highly recommend and encourage you to read through that and then reach out to us so that we can answer questions and do deep dive sessions. And to keep this session short, I'm going to just give you a high level summary. So for this particular security threat attack, we are actually deriving individual hash scores for each and every agentic tool call. And we are creating a list of those hash scores. And if there is a new tool which is actually getting triggered at runtime, we compute the hash score and then we can do the validation check with the existing list to see if that particular tool invocation is genuine or not. If that particular tool invocation is found to be not genuine, we block that straight away by applying the microsegmentation based policy control. That's to give you a high level overview in the interest of time. Next slide, Ken. So pretty much with these kind of techniques, you can do MCP based tool shadowing, security threat attacks, detection and mitigation. You can do MCP based prompt injection based security threat attacks that might be happening, or MCP based rug pull security threat attacks that might be happening in your environment. Now, I have seen some matured applications where people are trying to integrate MCP protocol with Google A2A protocol to build new kind of agents. Yes, even for such complex agentic workflows, Maestro threat modeling framework could be applicable and you can do threat modeling at ease. And with that, we are happy to take any questions if you might have, but thanks for the opportunity, team.
Great. Yeah, thank you, Akram. Thank you everyone for participating in this short talk. And if any question, reach out to Akram, LinkedIn, and myself, also the LinkedIn. Thanks.